In this video, we're going to be doing some vertical oscillation problems. Okay, so in a vertical spring, you have a state in which your string is maximally stretched and maximally compressed. So when you have the spring in motion like that, at its max compression and its max stretch, it creates a sinusoidal wave that is going to be cyclical, and it has cycles that are measured in periods and frequency. So in this question, what we want to calculate is the amplitude, the frequency, and the spring constant. So for this first question, we can look at our graph and we can find the minimum position and a maximum position. So we can see there's a min at 21 here, and we can see that there's we can see that a max is at 21, and then we can see that there's a minimum at 7. So then you can calculate your amplitude, which is equal to 21 minus 7 divided by 2. That's equal to 14 divided by 2, and that's going to be 7. So now after this, you need to find the period for this problem. So your period is equal to your cycles over your seconds. So let's see, cycles, it's equal to your time over your cycles. So let's look at how many seconds we have. So we have 5 seconds here, and we have 1, 2, 3, 4, 5, 6, 7, 8. So we have 8 cycles. So you can do 5 divided by 8, and that's equal to, if you plug that into your calculator, you have 0.625. Now after this, you can find your frequency. Your frequency is going to be defined as the reciprocal of your period, which is instead going to be cycles divided by time. And you can just say 1 over t. So that's going to be 1 over 0.625, which is going to be 1.60. Now after this, let's find the spring constant. So for the spring constant, your formula is going to be k is equal to 4 pi squared mf squared. So you have here 4 pi squared m. Here our mass is 159 grams, but you want that to be in kilograms. So it's 0.159 kilograms. So after this, you're going to put 0.159, and then you're going to have it times the frequency. Our frequency was 1.60, so 1.60 squared, that's going to be 16.1 if you plug that in for your k. So your amplitude is going to be in centimeters, and our frequency, we're going to have that in hertz, and our spring constant, it's going to be in newtons times meters. And yes, so now let's do another problem like this. So a 93 gram mass is placed on a spring with an unknown spring constantly. The mass has been set in its oscillation above a vernier motion sensor, and this is the position time graph that it generates. So we can count the frequencies, and we can also look at the amplitude here. So what we're going to do is, first we see from the graph, we're going to find our max and a min. So our max, we're going to have one here at 24.2 centimeters, and then we're going to have another, we're going to have a min at 8. That's the same for all of these. So your amplitude is going to equal to, let me actually move this down a little bit. Your amplitude is going to equal to 24.2 minus 8.0 divided by 2, the average of that. That's your midline. What you want, your amplitude is your distance from your midline, so that is going to be your positive a. That's going to be our negative a. And this expression, this is going to be 16.2 divided by 2. That's going to be 8.1. Now after this, you have to find your frequency. So your frequency, you're going to see oscillations over seconds. Just like before, here we have how many oscillations. See, we can have 1, 2, 3, 4, 5, 6, 7, 8, 9, and then a little bit more than a 9. So it's like 9.6. So 9.6 divided by 5 is equal to 1.92. So after this, now you have to find the spring constant. So k is equal to 4 pi squared mf squared. So now you're going to have 4 pi squared 0.09 4 pi squared 0.093 1.92 squared. So this is going to equal to 13.6. Now for our last example, we're going to do this graph. So for this graph, we can see that 29 is going to be our maximum, and we can see here our minimum of all of our sinusoidal waves, it's only going to ever go down to 13. So that's in centimeters. So our amplitude is going to be equal to 29 minus 13 over 2. So that's equal to 16 divided by 2, and that's equal to 8. After this, let's find our frequency. Again, our frequency is how many oscillations we have over oscillations divided by our seconds. And that's going to equal to, let's see here, it's a lot. So we have, let's count like this. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So we're going to say 16 here. 16 divided by how many seconds we had. This was in a 5-second time interval. And then that's equal to 3.20 is our frequency inside of our period. So now after this, if you wanted to, you can do your period, which is 1 over f, and that would just be 1 over 3.20, but I'm not going to calculate that. So now let's find our spring constant. K is equal to 4 pi squared mf squared. So that's going to be 4 pi squared. Here, what is our mass? Our mass is 77 kilograms, so we need to have that in kilograms, 0.077 kilograms, and plug that in here. 0.077 times our frequency, which we found is 3.20, so that's 3.20 squared, and then your K is going to equal to 31.1